Hey guys, I'm gonna go along with the matrices, and what we're gonna do today is something called determinants. Uh, Everything's part of one lesson. Like we used to multiply and do determinants. I'm breaking it up over this one lesson is gonna be the 3 days for the week, so hopefully that keeps it short. But we did this stuff. We did this stuff. Okay, this is where we left off. So determinants, right? If it's a square matrix, it has what's called a determinant, right? And we really only deal with 2 by 2s and 3 by 3s. 4 by 4s we're not even going to get into. Even 3 by 3s is kind of like the last day of the week. But um, it's people confuse this a lot with discriminants when we talked about like quadratics. It's a different word. It's called the determinant. And we're going to figure out why we need it in a second. But just for now, if we're ever asked to find the determinant of a matrix, right? Matrix have these brackets. If you ever see just straight lines, that means the question is going to be what is the determinant, right? So the determinant of this matrix is the exact same thing as saying this matrix ABCD with straight lines. Nothing to do with absolute value or anything like that. Just a different way to express that you're looking for the determinant, right? So you can kind of see like diagonal lines. Basically, as you go from left to right, right? If you're going down from left to right, that's what's going to be first. So you would multiply A times D, and then you would subtract B times C, which is kind of like right to left, or upwards from left to right, I guess. And whatever you get for the number value, right? These are all numbers inside here. That's what's the determinant. Now, if it's 3 by 3, it's kind of the same thing, but the problem is you can't keep going diagonally because you run out of room, right? The matrix stops after here. So there's a little trick, like if you repeat these first three letters and then these second three letters in the columns, right? So you get ADG over here, which is the first column repeated, and then BEH, which is the second column repeated, right? It's just like a tool that we can use so that we can create diagonal lines. Do you need them? No, you may be able to see, right? Certain people like visual learners, like, you can see that it's AEI and then it's BF. Oh, well, then it would be G and then C with the DA. Like, that's hard to see diagonals that way. So I usually recommend that you just write the first two columns out over here. And then it's basically the product, right? Well, the product of these three plus the product of these three plus the product of these three. Here's our blue ones. And then we subtract the product of these three, the product of these three, the product of these three. And whatever we get for the number value is the determinant there. It's just like the 2 by 2, but the 2 by 2 is, it's easier to do because only four numbers. When it's 9, it's easier to write out the columns twice, right? And we'll just do some practice. But all right, so if we want to know the determinant of this matrix right here, right? So again, two ways we could ask the exact same question. We could say determinant of this matrix 5, 3, 4, 1. Or we could just write it with bars, right? 5, 3, 4, 1. Both of these are asking the same question. What is the determinant, right? So, um, basically what we would do is say, okay, well, it's these two first, 5 times 1, which is going to be, whoops, I'm still on the highlighter. Well, here we go. It's these two first, and then we're going to subtract these two over here. And that's going to give us our final answer, right? So let me just get back to the pen. And so we're going to have 5 times 1, which is 5, minus 4 times 3, which is 12. So the determinant of this matrix is -7, just a number value. This one's a little trickier over here. So what I'm going to do is I'm going to write out the first two columns, which go 2, 4, 3, and -1, 1, -4. And all that's going to help me do is now I can draw my diagonals, right? So I'm going to do the diagonals. I'm going to do these plus these plus these, right? And then I can do that first. So that's going to give me, right, 2 times -2, so I'm going to get -4. Anytime there's a 0 in here, it makes our life easier. We're just going to say plus 0. You don't have to write that. And then -3 times -4 is +12 times 4 is 48. So that's the first part of it. I'm going to go back to my highlighter. And then I'm going to basically subtract the same things, but now going this way, right? My diagonal's going this way. I missed a little bit, but not bad. Right, so now I have negative 3 times 3, so it's going to be minus negative 9. The middle one, again, it's going to be plus 0. I'm running out of room, so I'm just not going to write it. So plus 0, and then negative 1 times negative 2 is positive 2 times 4, which is 8. So it's going to be minus, or I'm sorry, plus 8, right? Because I had negative, yeah. All right, so here we go. I got negative 4 plus 48, which is going to give me 44, minus negative 1 is going to be what I get from here, so it's going to be plus 1, and I'm going to get 45. So that's the determinant of this matrix. Why on earth do we use these? Well, again, determinants are really helping us to solve the real world problems, which we haven't really got to. This is all like the background information. But real world problems usually come in with systems of equations, right? So again, when we talked about systems of equations before, when you talked about in 8th grade, we have our 3 ways to do them, right? We can graph them to solve it. We can use elimination to solve it. And we can use substitution to solve it. This is a 4th way to solve a system of equations. It's one that you've never seen before. It's the only one you've never seen before. But it does work. Now, why on earth would you do it when the other ones work? Well, we'll get to it with a 3 by 3 matrix. It's very different. But for now, just keep in mind it might be easier to solve these with, a different, method. So again, what we're going to do here is this is called Cramer's rule, and it's a way to get solutions for a system of equations, right? These are all linear equations. They're just in standard form. Ax plus by equals c is technically standard form. They're using different variables, but we're okay. So if we have ax plus by and then cx plus dy, they're both in standard form, they're both lines. The coefficient matrix is, again, x's and y's. Those are part of the lines. You're not going to get rid of those. These are the coefficients. So what you do is you write the coefficients out in a matrix. So like, these are the variables that go with the x's, right, a and c. And the second column are the variables that go with the y's, b and d. E and f, which are what they're equal to, which are numbers, are not part of the coefficient matrix. So if we wanted to solve this system, right, and when we say solve it, your final answer is usually a coordinate with an x and a y coordinate. If you need to figure out the x coordinate, right, and we're going to use Cramer's rule to do it, the x coordinate is going to be this formula, and it's going to be the determinant, right? Remember, we have straight lines, so it's the determinant of the matrix with EFBD divided by the determinant of A, which, what is A? What the heck is A? A is our coefficient matrix. I should probably write that, right? I'm just going to label as A, but it should say determinant of coefficient matrix. A is a little easier than saying that. And so what you notice is this B stayed the same, this D stayed the same, but all of a sudden, if I'm comparing this matrix to this one, the A got replaced with the E, and the C got replaced with the F, which is exactly how you solve for the X variable, right? So basically what it is you remove the X coefficients, which were A and C, and you replace them with what they were equal to, right? What each equation is equal to, so E and F. So if you can, like, if you want to pause the video and make a guess about what the Y coordinate is, it really follows the same rule. And that rule is basically going to be the A and the C are going to stay because we're solving for the Y. And these E and F's are now going to replace the two coefficients that were in front of the Y's. So this one doesn't have B and D anymore. It replaced it with E and F. So it's the determinant of that matrix, which is totally new, divided by the determinant of this one. Right? So we'll do a practice problem. So here we go. We have two lines right here, the system of equations. Keep in mind you could easily multiply the bottom one by 3, and it would be a pretty simple elimination problem. We're going to make it harder with doing Cramer's rule. But there is an advantage to doing this, and I'll explain that in a second. So with Cramer's rule, right, we're going to say, okay, our coefficient matrix is going to be, we're just looking at the coefficients, so I have 9 and 3 for my x's, 9 and 3. And then I have 4 and negative 5, 4 and negative 5 for the y's, right? Now, I'm gonna need to figure out what the determinant is here. So I'm just gonna write that right below it. So 9 times -5 is -45. And then I subtract the other one, -12 is gonna be -57. Not necessarily the easiest number to work with, but that's what our determinant is. Okay, so the x-coordinate, right, again, I'm finding the solution to these equations, so my answer is going to be a coordinate. If I want to know what the x-coordinate is, it is the determinant of, kind of like the coefficient matrix, the y's are going to stay the same. It's going to be 4 and -5, but I'm replacing the x coefficients, 9 and 3, with these two numbers here, -6 and -21. Okay? And then I divide that by the determinant of my coefficient, which was the -57, right? And I'm hoping I get a nice, easy answer. So here we go. I got -6 times -5. I'm finding the determinant of this. I got straight lines. So -6 times -5 is going to give me 30. And then I need to subtract 4 times -21. So 4 times +21 is going to be 84. So minus -84 is going to turn to +84. And that is going to give me 114, right? Which, if I look at that, right, so that's my numerator, divide it by -57, and that's going to give me a nice clean answer of my x coordinate, which is just -2, right? If I want the y coordinate, now keep in mind I could just plug in x and then solve for y, which would be easier, but I'm going to do it out with Cramer's rule with the y coordinate. So the y coordinate is going to be equal to the determinant. Same thing, it's going to be divided by the determinant of my coefficient matrix, so -57. But now I'm going to have, I'm going to keep the 9 and 3, but instead of my y coefficients 4 and -5, I'm going to swap them out with the -6 and the -21. So I got 9, 3, -6, -21. And, 9 times -20 is -180. So if I subtract another 9 from it, I get -189. And -6 times 3 is minus, so I'm going to be minus, and then a -18, right, or +18. So that's going to give me -171. Again, I need to divide that by the denominator, which is -57. And if I do that, right, 114, I know this was the other answer. If I added 57 to 114, I would get 171. So this answer here is a nice clean +3. So the answer to my system is -2, +3. And you could check that, right? 3 times -2 is -6. Minus 5 times 3, so -15 does give me -21, right? It works. All right. So it's a 2 by 2 matrix. Now, if it's a 3 by 3 matrix, it kind of follows the same rule. You have your coefficients here. But now with a 3 by 3 matrix, we have a third variable. This is where it becomes important to us, right? So we have a third variable that we want to solve for, which is z, right? We have x, y's, and now z's. So I'm going to write the coefficient matrix as all of the coefficients, all 9 of them, out. Now the A, the D, and the G went with the x's, the B, the E, and the H went with the y's, the C, the F, the I went with the z's. And then it's very similar, right? So the x coordinate would be if I replaced all of the x coefficients with whatever is equal to, so j, k, and l, right? So it's the same BEH, CFI, BEH, CFI, but now the x coefficients are replaced with my answers. For the y coordinates, it's the same thing, but now I'm putting the j, k, and l for the y coefficients. Again, all over the determinant of your original matrix here. And then the z, the j, k, and l go with the go with the z coefficients. I'm not actually going to do one. They take a while. That's going to really be tomorrow. So that's it. You guys have a few practice problems, and hopefully you get it. Thanks.